Good day everyone. Today we're going to discuss about parabola. The learning outcomes of the lessons are: first, we need to define a parabola. Second, determine the standard form of equation of parabola. Third, graph a parabola in a rectangular coordinate system. And solve situational problems involving conic sections, and that is parabolas. Let us define now parabola. Parabola is a set of points in a plane that are equidistant from a fixed point F and fixed line L not containing F. So based on our illustration, the fixed point is what we call the focus, and the fixed line is our directrix. So this is the uh, fixed point, that is the focus, and this is the fixed line or the line directrix natin. Okay? So now, let's proceed to the important information about parabola. So based on the illustration, point focus, this one, is equal to point directrix, this one. So that is PF is equal to PD. Next is, the parabola has one axis of symmetry which intersects the parabola at its vertex. So this is our axis of symmetry that intersects the parabola at its vertex. And then we have also the absolute A. So it is always the distance from the focus to the vertex or the distance from the vertex to the directrix. So if you want to find for the distance from focus to the directrix, that is equal to A, or vertex to the directrix, that is also equal to A. Or if you want to get for the distance from the focus to the directrix, that is equal to 2A. And then, what is the relationship of focus and directrix to the vertex? Vertex is the midpoint between the focus and the directrix. And we have also the latus rectum, and or that is LR. It is a chord of a conic sections, passes through a focus, and it's parallel to the directrix. So from here, say the latus rectum, the distance of that, so from one end of the parabola, and also here, it passes through the focus. Now let's proceed to standard form equation of parabola. For a parabola with the axis of symmetry parallel to the y-axis and vertex at h and then k, the standard form is, because we all know in parabola there are many orientations, so we'll look for the orientation of the parabola. So the standard form, it depends also to the orientation of the parabola. So but this time we have now the squared of the difference of x and h is equal to 4a times the difference of y and k. So means to say that if the axis symmetry is parallel to the y-axis and the vertex at h and then k, so the parabola is opens upward. So we're going to use this formula of the standard form equation of a parabola. The axis of symmetry is x is equal to h. So if you want to find for the axis of symmetry, that is equal to h. And to find for the focus, that is equal to h comma k plus a. And then For the directrix, that is equal to y is equal to k minus a. And then when a is positive, the parabola opens upward. So means to say we can determine if the standard equation is when we graph that or the orientation of the parabola is opens upward or downward or even sideways. It depends on the the sign of the a. If a is positive, the parabola opens upward. Okay? And when a is negative, the parabola opens downward. Okay? So always remember also if our standard equation is in the form of like this, the squared of x minus h is equal to 4a times y minus k. If x is being squared, so the orientation of the graph of the parabola will be opens upward or downward. To be exact or to be specific, what is the orientation of the parabola? It opens upward or downward by the sign of our a. Okay? And then next. So this time, for a parabola with the axis of symmetry parallel to the x-axis and the vertex at h and n k, the standard form is, so a while ago, so the axis of symmetry parallel to the y-axis and the orientation of that graph of the parabola opens upward or downward or vertical. Now, for the axis of symmetry parallel to the x-axis, the parabola or the orientation of the parabola is open sideways. Okay? So the formula that we're going to use to find for the standard form equation of a parabola, that is equal to the square of the difference of y and k is equal to 4a times x minus h. Again, the axis of symmetry is equal to, that is y is equal to k. And for the focus, we have h plus a comma k. And we have directrix, and that is x is equal to h minus a. Again, same scenario on what we did for the axis of symmetry parallel to the y-axis. So when a is positive, the parabola opens to the right. Okay? When a is negative, the parabola opens to the left. Okay? So if this time, if y is being squared, then the orientation of the parabola opens sideways. So either to the left or to the right. It depends to the sign of our a. Okay? Now, this is the summary of the standard form equation of parabola where our vertex is at h and then k. So this is the equation, the graph, the focus, the directrix, and the axis of symmetry. Okay? And then for the vertex, and that is 0, 0, this is also the summary. So now, how to graph a parabola in a Cartesian plane? We have also steps on that. So step 1, make sure that the equation is in standard form. Step 2, locate the focus. Step 3, draw the directrix. Step 4, locate the vertex, and that is h and k. Step 5, locate 2 points that satisfy the definition of a parabola. Step 6, connect the points in a smooth curve. Now, let's have an example. Number 1, so we're going to apply all the concept of the parabola here, for example number 1. So, for example number 1, find the vertex, focus, directrix, and axis of symmetry of the given parabola. X squared is equal to 4y. Again, so I want you to observe our equation. So this is x squared is equal to 4a. So if you're going to observe that, so x is in squared now. So the orientation of our parabola will be open, upward, or downward. Okay, this is opens upward or downward because x is in the squared. Now to determine if this is upward or downward, if our numerical coefficient of y is positive, then the orientation of the graph is opens upward. If that's negative, downward. But this time, we have 4a and that is positive, it opens upward. So let us try, or let us see. So, again, to determine the value of a, so we're going to use 4a is equal to 4 and that is 4 here, numerical coefficient of y, and then to divide by 4 to have the value of a. A now is equal to 1 unit. So a is positive, means to say the parabola opens upward. So our vertex now is 0, 0, simply because our h and then k, or the center, the vertex is at the origin. And then the focus is 0, 1. Okay, we all know that the focus, to find for the focus, that is h, comma, k plus a. Since a is 1 and k is equal to 0, therefore our focus is at 0, 1. And then the directrix, and that is y is equal to negative 1. Okay, because we have a, so from the vertex, and we have a that is 1, so move, so from above the vertex, that is the focus, that 1 unit, and below the vertex 1 unit away from the vertex, and that is the directrix, or the fixed line. Okay, and also the axis of symmetry is equal to x is equal to 0. Okay, to graph that, so we have now a vertex, and our a, we all know that the distance from the vertex to focus, that is equal to a, and our a is 1 unit above the vertex, that will be our focus. Now the focus is at 0, 1, and to find for the directrix, that is 1 unit below the vertex. So we have now here at negative 1. So y is equal to negative 1. Okay, so the directrix must be in the form of equation. Okay, so let's proceed to example number 2. Sketch the graph of the parabola with equation y squared minus 2x is equal to 0. Indicate its focus, directrix, axis of symmetry, and latus rectum. So we have a typographical error here for the graph, so consider this graph, so remove G. Okay, again, same scenario of what we did in example number 1. So we need to determine our equation, and that is y squared minus 2x is equal to 0. Okay, so the squared is in the term of y. So the orientation of the parabola will be sideways. But we need to determine that if that is opens to the left or to the right, it depends on the sign of our numerical coefficient of x. Okay? But we need to solve for our a to determine if that is opens to the left or to the right. So again, we have now 4a is equal to 2, and then divide both sides by 4. A now is equal to 1/2 unit. So A is positive, so our orientation of the parabola will be opens to the right. Okay? So our vertex also, that is 0, comma 0, so at the origin. And we have the focus, we all know that is our A is 1/2 unit away from the vertex. So we have now 1/2 comma 0, that will be our focus. And the directrix, and that is above the what we call this one, beside the vertex, and that 1/2 unit also away from the vertex. So we have now x is equal to negative 1/2. And the axis of symmetry, y is equal to 0. And to graph that here, and our latus rectum is 2 units. Okay? So this is the graph of y squared minus 2x is equal to 0. Therefore, the orientation of the parabola is opens to the right. Okay? And the latus rectum, that is 2. The distance, that is 2. So that is passes through our focus. Okay? So here. Okay, next. Example number 3. Find the vertex, focus, directrix, and axis of symmetry given the equation of the parabola. So we have now the square of the sum of x and 1 is equal to negative 2 times y minus 1. Again, I want you to observe our equation or standard form equation of the circle. This time, we have now the vertex at what? That is in negative 1 and 1. Okay, but we need to determine first the orientation of this graph. What will be the orientation of the graph? Since x plus 1 is squared, so x is in the squared now, then we're going to determine now our a. So if a is positive, by the way, is since x is in the squared, so the orientation of our graph will, that is vertical. So opens upward or downward. So to check if that is opens upward or downward, we need to find for the value of a. So we have 4a is equal to negative 2. Then divide both sides by 4. A now is negative 1/2 unit. So a now, since a is negative, therefore the orientation of our parabola will be opens to the left. To the opens downward, sorry. That is opens downward. Okay? Now, the vertex is at negative 1, comma 1, and our focus, that is h, comma, k minus a, where h and k, that is negative 1 and 1. Okay, so, and then our a is 1/2. So we need to subtract that to our k, so that will be 1/2. So negative 1, comma 1/2. And axis of symmetry is x is equal to negative 1. And the directrix, y is equal to k plus a. Our k is 1 and a is negative 1/2. So k minus 1/2 is 1/2. So the graph of that is opens downward. Okay, so look at, kindly observe our graph. So this is now the graph of the squared of x plus 1 is equal to negative 2 times y minus 1. Now let us proceed to example number 4. Find the standard and general equation of the parabola with a focus at 2, comma 4 and the directrix at x is equal to 8. Okay, so this time we need to find for the standard and the general equation of the parabola given the focus and the directrix. So what we're going to do here, so the distance from the focus to the directrix is 6 units. Okay, so how we know that the directrix is 6 units? So by getting the difference of 2 and then 8. Okay, so that is absolute. So, or maybe you're going to subtract 8 minus 2 and that is 6. So we have now 2a is equal to 6. So 2a over 2 is equal to 6 over 2. A now is 3 units. Okay, so why do we use 6? Simply because the focus of the directrix, we all know that the measure from the focus to the directrix, that is equal to 2a. Okay, and the measure of that is 6 units. So we're going to equate now by 2a is equal to 6. So we have now a is equal to 3 units. Or by getting 2a is equal to the absolute value of 2 minus 8. So 2a is equal to the absolute negative 6. 2a is equal to 6 divided by 2a is now equal to 3 units. Okay, so that is distance from vertex to focus 3 units, and vertex to the directrix, that's also 3 units. Okay, now the vertex is 5 comma 4, and then our standard equation now will be y minus 4 squared is equal to negative 4 times 3 times x minus 5, because a is equal to 3, so we substitute it now. Okay, and then simplify, we have now the squared of the difference of y and 4 is equal to negative 12 times x minus 5. So this is now the standard form of the equation of parabola. And then to find for the general equation, so we need to expand our standard form. So we have now y squared minus 8y plus 16 is equal to negative 12x plus 60. And then simplify them, we have now y squared minus 8y plus 12x minus 44 is equal to 0. This is now our general equation of a parabola. And then to find for the axis of symmetry, y is equal to 4. And to graph that, so the orientation of this example number 4, or our equation, the squared of y minus 4 is equal to negative 12 times x minus 5 is opens to the left. Okay, so we indicate all the properties of the parabolas there. Now let us proceed to example number 5. For example number 5, find the latus rectum and the equation of the parabola that has a minimum at negative 2, 6 and passes through the point 6, 14. We need to sketch the graph. So our solution now will be x minus h squared is equal to 4a times y minus k. So we're going to use this uh, formula of standard equation of parabola where x is equal to 6 and y is equal to 14. Okay, and then substitute. So we need to find for the value of a first because we don't know what is the value of a. Okay, but this time since negative 2 and 6 and passes through the point 6 and then 14, so if you go into graph that, the orientation of the parabola will be opens uh, vertically, but we don't know if this is opens upward or downward, and that is the reason why we need first to find for the value of a. So we need to substitute 6 comma 14 and negative 2 and 6 to our formula of standard equation of parabola. So we have now the square root of the difference of 6 and negative 2 is equal to 4a times 14 minus 6. So we have now the square root of the sum of 6 and 2 is equal to 4a times 8. Then simplify, we have now a squared is equal to 32a. 8 squared is 64 is equal to 32a. Then divide both sides by 32. A now is equal to 2. Since a is positive, therefore the orientation of the parabola will be opens upward. Now, to find for the standard equation, so we need now to substitute a by 2 from our given. So we have now x minus the squared of the difference of x and negative 2 is equal to 4 times 2 times y minus 6. And then simplify, we have now x plus 2 squared is equal to 8 times y minus 6. This will be our standard form of the equation of parabola. Okay, now to graph that, we need to first to find for the focus, and our focus, and that is h comma k plus a. Okay, so our h is negative 2 and our k is 6 and our a is 2. So we have now the focus, and that is negative 2 comma 8. Next is we need to graph our equation. So this is the graph of our equation of this, the square root of the sum of x and 2 is equal to 8 times y minus 6. So we have now the minimum, and that is we have passes to the point 6 and then 14, and then the minimum will be our vertex, and that is negative 2 comma 6. And then the green one, that will be our axis of symmetry that passes through the focus and the vertex. Okay, so now let's proceed the situation or problem involving parabolas. So the cable of suspension bridge hangs in the shape of a parabola. So the towers supporting the cable are 400 feet apart and 150 feet high. If the cable at its lowest is 30 feet above the bridge, at its midpoint, how high is the cable 50 feet away horizontally from either tower? So look at for our illustration of our suspension bridge hangs in the shape of parabola. So here, so that is distance that is equivalent to 400 feet, and we consider that the center or the vertex of this hanging a suspension bridge hangs in the shape of a parabola, and that is 0 comma 30. Okay, so we're going to use now the formula, and that is x squared is equal to a times y minus 330. So our k there is 30. Okay, so because we have now h comma 30, and our h is 0 and k is 30. Now we're going to substitute now the value of our x, since our x is 200 here. So we have now 200 squared is equal to a times, and this, we need to substitute the value of y because we need to find for the value of a. So we have now a times 150 minus 30, and then simplify. We have now 200 squared over 120, and if we're going to simplify that, a is equal to 1000 over 3. But we're not yet done, so we're going to substitute a now from this formula, from this equation. So the parabola's equation x squared is equal to, we need to substitute a, and that is 1000 over 3 times y minus 30, or equivalent to y is equal to 0.003x squared plus 30. So what we did is we substitute now, we cross multiply them, or if you want, you're going to simplify 1000 over 3. Okay, and then do the manipulation to make it y is equal to 0.003x squared plus 30. And then after that, so we have for the 2 points on the parabola here, so we have 50 feet away from the tower, x is equal to 150, or x is equal to negative 150. If x is 150, so we're going to substitute now, okay, from our from this equation. So substitute x for us to have the value of y. So we have our x is equal to 150 because here, so we have now y is equal to 0.003 times 150 squared plus 30. And then if you're going to simplify that, the answer for y is equal to 97.5. Therefore, the cable is 97.5 feet high, 50 feet away from either tower. So as expected, we get the same answer from x is equal to negative 150. Okay, so thank you. That could be all.